Section 9.5 is about completing the square, but before we can figure out what completing the square means, we need to talk about perfect square trinomials. So remember, a trinomial is a polynomial with specifically 3 terms. And what makes it a perfect square trinomial is the fact that when I factor it, I'll end up with a parentheses squared. So here's 2 examples. If I have x squared plus 8x plus 16, I need to think about what 2 numbers multiply to give me 16 that add up to give me 8. So that would be x plus 4 and x plus 4, which I can simplify into x plus 4 squared. So I had a trinomial that got broken down into a perfect square. Same thing goes for this. If I have 4x squared minus 12x plus 9, I'm going to break that down. Remember, if the first number is a perfect square and the last number is a perfect square, in your first and last chart, you should try their square roots to see if you can get that number in the middle, which we do. 2 times 3 is 6. 2 times 3 is 6. Since it's a minus plus, I know it's going to be a minus minus, so these numbers would be negative, and I get a negative 12 in the middle. So basically, I'd end up with 2x minus 3 times 2x minus 3, which again, I can simplify down to 2x minus 3 squared. So once again, I have a trinomial that gets broken down into a perfect square. So what we're going to be doing in this section is figuring out how can we make our quadratic equations into perfect square trinomials, which will make graphing and solving them easier to do down the road. So once again, we're going to be doing something called completing the square. So this is what it looks like. It says, in words, to complete the square for the expression x squared plus bx. So we're only going to start off with the square term and the middle term. So it could be like x squared plus 4x. The way you're going to complete that square is by adding the square of half the coefficient of the term bx, which that seems very confusing. Basically, all you're going to be doing is you're going to be taking this b term, dividing by 2 and squaring it. So again, and this is the part that I want you to write down, to complete the square, you divide by 2 and square it. So you take your b value, divide it by 2 and square it. So here's an example. If I had x squared plus 6x, and I want to figure out what would I add to that to make that a perfect square trinomial, I take my b term, I divide it by 2, and I square it. So 6 divided by 2 is 3. 3 squared is 9. So this is now a perfect square trinomial. So when I break it down and I want to factor it, I would figure out what 2 numbers multiply to give me 9 that add up to give me 6, which that would be 3 and 3, which gives me my perfect square trinomial broken down into factored form. So again, we're trying to figure out what we're going to add to x squared plus bx to make it a perfect square. Let's see some more examples. So here's example number 1, our first formal example. Find the value of c that makes the expression a perfect square trinomial, then write the expression as the square of the binomial. So just like I did in the slide before. So here's part A, x squared plus 8x plus c. So we're trying to figure out what is the c value that would make that a perfect square trinomial. So what you do is you take your b value, which in this case is 8, divide it by 2, and then square it. So 8 divided by 2 is 4. 4 squared is 16. So x squared plus 8x plus 16 factored would be 4 times 4 is 16, 4 plus 4 is 8, so I'd end up with x plus 4 squared for my perfect square binomial broken down in factored form. For part B, we have x squared minus 12x plus c. So this time I have a negative, so I can still keep it negative. So I'm going to take my b value, divide by 2, and square it. So negative 12 divided by 2 is negative 6. And then when I square it, no matter what I do, anytime I square a number, I'm always going to end up with a positive answer. So no matter if I thought of that as negative 12 or positive 12, when I square the negative 6 or the positive 6, I'm still going to get positive 36 as my completing of the square term. So I'd end up with x squared minus 12x plus 36. And when I break that down into factored form, the 2 numbers that multiply to give me positive 36 but add up to give me negative 12 would be negative 6 and negative 6. So I'd end up with x minus 6 squared as my factored form of that perfect square trinomial. And part C, we have x squared plus 3x plus c. So again, I take my b value, which in this case is 3. I divide by 2, and I square it. But in this case, 3 divided by 2 is not going to give me a whole number. So what I'm going to end up doing is I'm just going to take 3 and square it, and then square the 4. So my C value is actually going to be 9/4. And you can leave that as a fraction or change it to a decimal. It doesn't matter. It all means the same thing. So there's my perfect square trinomial. So when I break it down into factored form, it would just be x plus 3/2 squared. I noticed that every time I divided by 2 and then squared it, before I squared it, that number that I got in here is the number that ends up in the parentheses. So 8 divided by 2 is 4. So when I broke it down, it was x plus 4 squared. Same thing here. When I took negative 12 divided by 2 is negative 6. And then when I broke it down, it was x minus 6. So to make it easier on here for problem C when I had the fraction, I just remembered that the number that ends up in my parentheses here when I go to factor my perfect square trinomial is just the number that I got after I divided by 2. So when I took 3 divided by 2, I just left it as 3/2, so that's what would end up in my parentheses when I factor it down. So we're learning how to complete this square and turn our equations into perfect square trinomials so that we can use this method to solve quadratic equations. So the method of completing the square can be used to solve any quadratic equation. To do so, you must first write the equation in the form of x squared plus bx equals d. So basically you want the squared term and the middle term, the term with just the x, on the left-hand side, and any constant term needs to be on the right-hand side. So let's see some examples of using the completing the square method in order to solve our quadratic equations. So here's example number 2. It says solve round answers to the nearest hundredth if necessary. So our first problem says x squared plus 6x equals 7. So the first thing I notice that it is in the form that I was told to put it in, where the squared term and the x term are on the left-hand side and any constant terms on the right-hand side. I like to rewrite the equation at this step so that I have some blanks, because what I'm going to end up doing is adding a term here by completing the square to make this side a perfect square trinomial, and whatever I add to this side of the equation, I'm going to have to add on to this side of the equation to keep my equation balanced. So I'm going to say 7 plus blank on the right-hand side. So now I'm going to complete the square. So if I have 6 as my b term, I take that number, I divide by 2, and square it. So 6 divided by 2 is 3, 3 squared is 9. And if I add 9 to this side, I have to add 9 to this side so that my equation again stays balanced. So now that I've made this side of the equation a perfect square trinomial, I'm going to factor this down. So remember, in parentheses, the number that you put here will be the number that you got after you divided by 2. So 6 divided by 2 is 3, so I'd have x plus 3 squared. So that basically means that 3 times 3 is 9, 3 plus 3 is 6. So when I have x plus 3 times x plus 3, I just simplify it to x plus 3 squared. And that would be equal to 7 plus 9 is 16. So now we think back to the last section when we solved equations by using square roots. So I would just take the square root of the left-hand side to get the x plus 3 by itself, which means I got to take the square root of the right-hand side. So the square root of x plus 3 squared is x plus 3. And then the square root of 16 is plus or minus 4. So then I would just subtract 3 from both sides. Remember, I have to subtract 3 from the 4 and the negative 4. So 4 minus 3 is 1, and negative 4 minus 3 is negative 7. So my two answers are 1 and negative 7. So keep in mind, this means that if I had graphed this equation, the x-intercepts would have been at 1 and negative 7. Let's look at part B. We have x squared minus 2x equals 3. So again, we see that it's in the form that we need, where the x squared and the x term are on the left-hand side and the constant terms on the right. I rewrite this with the blanks, so I remind myself whatever I add to the left, I'm going to also add to the right. Remember, when I complete the square, I'm always going to be adding a positive number, so that's why we just have a plus and a plus. So then I actually complete the square. I take my b term, which is negative 2, I divide by 2, and then I square it. So negative 2 divided by 2 is negative 1. Negative squared is 1, so that's what I would add to the left and also to the right. So now when I break it down, remember the number that ends up in my parentheses is the number that I got after I divided by 2. So negative 2 divided by 2 was negative 1, and that's because negative 1 times negative 1 is positive 1, and negative 1 plus negative 1 is negative 2. So I'd have x minus 1 squared equals 4. So then I just take the square root of both sides. So I have x minus 1 equals plus or minus 2. So I'm going to add 1 to both sides. So I'm going to add 1 to positive 2 and to negative 2. So I'd get x equals 2 plus 1 is 3, and negative 2 plus 1 is negative 1. So again, this means if I had graphed my original equation, that parabola would have gone through the x-axis at 3 and negative 1. So here's two more examples where we're going to be using the completing the square method in order to solve our quadratic equations. But notice that these two problems are a little bit different because there's numbers in front of our x squared term. So the way we're going to approach these problems is we cannot complete the square if there is a number in front of your squared term. So we need to get rid of it. So what we'll do is whatever that number is, I'm going to divide my entire equation by that number. Every term in my equation is going to be divided by like your a value. So in this case, it's 2. So 2x squared divided by 2 is just x squared. So we got rid of it. 20x divided by 2 is 10x. Negative 8 divided by 2 is negative 4. And then 0 divided by 2 is 0. So now that I've gotten my x squared term by itself, I got rid of that a term. Now I'm ready to set up the equation so that I can complete the square. So remember, any constant term needs to go to this side. So we would have x squared plus 10x, and again, I'm going to put a plus blank here, equals 4 plus blank. So again, you take your constant term, put it on the other side. So it was minus 4, so now it becomes plus 4 on the right-hand side, and then I put my plus blank on the left and my plus blank on the right, so I can complete the square. So I take my b value, which is 10. I'm going to divide by 2 and square it. So 10 divided by 2 is 5. 5 squared is 25. So if I add it on the left, I got to add it on the right. So now I'm ready to turn my perfect square trinomial into a factorable term. So remember, whatever goes in your parentheses is the number that you got after you divide it by 2. So in this case, it would be 5, because 5 times 5 is 25, and 5 plus 5 is 10. So I have x plus 5 squared equals 29. So when I go to solve it now, I'm going to square root both sides. So I'd have x plus 5 equals plus or minus 29 is not a perfect square. So if I take 29 and in my calculator I take the square root of it, I'm going to get a decimal. I want to keep this as exact as I can, so I'm just going to keep it as plus or minus the square root of 29 and not change it to a decimal. So when I subtract 5 from it, I can actually write this as x equals negative 5 plus or minus the square root of 29. That would be my exact answer. Basically, all I did was took that minus 5, put it in front here, and said negative 5 plus or minus the square root of 29. So what you can do now is just find your decimal approximations. You're going to take negative 5 plus the square root of 29 in your calculator and negative 5 minus the square root of 29 in your calculator. And I got about 0.39 and negative 10.39 for my two answers. Let's move on to part D. So again, we have 3x squared plus 12x minus 18. So again, we cannot do the completing the square method if there's a number in front of your x squared term. So I'm going to divide my entire equation by that number. So 3x squared divided by 3 is just x squared. 12x divided by 3 is 4x. Negative 18 divided by 3 is negative 6 equals 0, because 0 divided by 3 is just 0. So now I got to set it up so I can actually complete the square. So remember, I keep my x squared term and my x term on the left-hand side. I'm going to put plus blank. I'm going to move this minus 6 to the right-hand side, so it becomes plus 6 on the right-hand side, and I got to put my plus blank there to remind myself that whatever I add here to complete the square, I also have to add to the right-hand side to keep my equation balanced. So now I'm ready to complete the square. I take my b term, which is 4. I'm going to divide by 2, and I'll square it. So 4 divided by 2 is 2. 2 squared is 4. So whatever I add to the left, I have to add to the right. So now let's factor it. So x squared plus 4x plus 4 would be x plus 2 squared. And then 6 plus 4 is 10. Take the square root. Just like before with the 29, 10 is not a perfect square, so I'm just going to leave it as x plus 2 is equal to plus or minus the square root of 10. So when I subtract 2 from both sides, I would just write it as x equals negative 2. I'm just going to put that minus 2 out in front here, plus or minus the square root of 10. So I would get my two answers by taking -2 plus the square root of 10 in my calculator. Then I'll go back and do -2 minus the square root of 10 in my calculator. So my approximations would be about 1.16 and -5.16. So again, what this means for actually in both cases, that if we were to actually graph these two equations, the parabolas would have hit the x-axis at these 2 points for part C and these 2 points for part D. That's it for this section. Make sure you jot down anything you didn't understand that we can cover in class before we move on, and we'll see you then.